Hello everyone and welcome back to Getting Started with World Creator 2. I'm Tyler, and in this video we are finally going to get to talk about the process from taking your landscape design from World Creator 2 and importing that into Unreal Engine 4. Now there are a few ways to do this. For example, we could just import the entire terrain as a whole into Unreal Engine, or we can split the terrain up and import it using World Composition, or we can even use the UE4 sync tool. But for this video we're just going to be talking about how to understand the UE4 landscape and how to import the main landscape from World Creator 2 as a whole. And in the next video, we're going to break it down into how we can split it up into World Composition. But for now, before we get into it, I want to cover exactly how the terrain sizing works in Unreal Engine, as it is a little bit different from other engines. So if you already know this, then go ahead and skip this section. I'll be sure to keep timestamps included in the description so you can skip ahead. And let's get started. So unlike other engines, Unreal has optimized their terrain rendering in such a way that the terrain resolutions end up being a more unconventional size, to say the least, than most users might be used to. To break it down on exactly how these resolutions are different, let's look at each area of how the terrains are sized, and that might help you understand a little bit better. Looking at this, let's say this square is our terrain, and we divide this terrain evenly into 4 total pieces. In Unreal Engine, each one of these pieces is called a component. A single component is Unreal's basic unit of calculation for rendering, visibility, and collision of the terrain. You could think of each component as the first LOD in the landscape, but technically speaking, each component is a single draw call for your system. We can cover this more in depth later on, but let's go ahead and zoom in and focus our attention to break down just one of these components. So for each component, you have the option to divide it up into component sections. Here, I've divided this single component into 4 total sections. Now keep in mind, components can only be divided into 1 by 1, so 1 section per component, or 2 by 2 sections, or 4 sections per components. We'll break this down in just a little bit, but basically a section component is Unreal's base unit of first level of detail. So let's look at these couple examples on how each section is optimized to be the first level of detail. If we have a terrain with 4 by 4 components, and each of these components only has 1 by 1 section, and if we compare that to a terrain with 2 by 2 components, and each of those components has 2 by 2 sections, each of these terrains technically equals to an overall equal grid of 4 by 4 quads. However, since the terrain with less components on the right has been subdivided with more sections, it will perform much better in rendering due to the LOD calculations of the engine in the way it has been divided with each component section. So as a rule of thumb going forward, it is best to fill each component with a 2 by 2 section while having as little components as possible, because that's just less work that your computer has to do in order to provide the amount of detail of your terrain. It is just better to optimize performance sake for your workflow, and for if you're rendering this out, it's a much smoother experience. That little bit set aside, let's go back and focus to our single component here, which we have divided into 4 component sections. So let's zoom back in again, and let's just this time take a look at just one of these 4 sections. Here within each section, we must divide how many quads we want to subdivide the section into. This will be Unreal's next level of detail that drives the vertices to generate the height values. So as a crash course, a quad is comprised of 4 vertices, 1 at each corner of that quad. This section we zoomed in on is technically already 1 quad, just like a single component is 1 larger quad. Anyways, a quad being 4 vertices is a power of 2, so we need to ensure that the total number of vertices in each section is a power of 2. So if we subdivide this component section into 4 quads, that won't fly because it produces 3 by 3 vertices, or 9 by 9 vertices total. That, as I'm sure we all know, is not a power of 2, so we need to subdivide this section into an odd number of quads to get an even number of vertices. Trust me, it all makes sense later once we get down to it. For example, dividing this section into 3 by 3 quads produces 4 by 4 vertices, which is a power of 2 in vertices. Or we can do 5 by 5 quads to produce 6 by 6 vertices. Do keep in mind though that there is a maximum number of 256 by 256 vertices in a single section in Unreal. This is all due to the technical aspects that they've come up with on the performance optimization that we've slightly mentioned before in the beginning. Now, the real reason why the quads within a section have to be a power of 2 vertices all has to do with the level of detail coded in the system, as we've mentioned, with regard to how the bitmaps or the texture maps for the landscape textures are displayed on the terrain. So it has to do with the distance calls and the complexity that the terrain is displaying the texture in relation to the view distances from your camera. It's all technical, but ultimately it's Unreal's performance optimization that you unequivocally have to adhere to. So now that if we look at all the pieces together that we just went through, so here we have the entire terrain with the section that we had just applied. And then if we fill those sections into one component, you can see there's 4 sections per one component. And let's just go ahead and add the rest of these sections into the entire terrain. So now, as you can see, we have one terrain with a 2x2 component. Each of these components is comprised of 2x2 sections. And if you look closer at the individual sections, you'll see that each of those has 3x3 quads. So if you take all of the quads in this terrain and you add them up by X and Y values, you get 12 by 12 quads. And remember, we have to add +1 to that 12 to get 13 by 13 vertices. This 13 by 13, as you can see here, is actually going to be our full terrain resolution that we would use in third-party apps or really just in Unreal Engine 4 on how it's scaled properly. To skip all the little nitty-gritty details and to make it easier for you guys to come up with a terrain size that actually works for Unreal, just follow this equation that I've put up here on the screen. So to start off, you have to decide the number of quads per section. And once you have that number based on these predetermined numbers that I have put up here, times the number of sections per component, which as we've learned is either 1x1 or 2x2 sections per component. That number times the number of components total, which you can choose any number between 1 and 32. Once you've added all of those together, you have to add +1 vertice to complete the equation, and now you have your resolution or your terrain size for one X or Y value. These decisions in this equation should help you achieve the correctly sized terrain in UE4. However, if you want to skip all of the math and just get something predefined so you can get straight to working and not bother with any of this nonsense, in Unreal technical documentation that you can see here, they have a list of recommended landscape sizes already broken down for you and how to use. For the purposes of this video, we're just going to pick one of these sizes to use in World Creator 2 to start off with. Let's just choose 4033 by 4033. So here we are in World Creator 2, and let's just go ahead and make a quick terrain here. But first, as I said before, let's change this 2048 to 4033. Let that generate real quick, and here we are. 1 meter precision is fine. We're going to cover some different things, precision a little bit later. But for this first round, we're going to start off with 1 meter, and our actual resolution, as you can see here in pixels, is 4033 by 4033, which, as we've learned before, is one of UE4's recommended terrain sizes. So I'm just going to quickly make a sample terrain here for us to use real fast. Okay, we have our sample terrain here, and I'm actually going to do one more thing so that we can illustrate exactly the orientation of this. I'm going to add a north and south little stamp on here. So what I'm going to do real quick is I'm going to go to areas, add an area, fit that area to terrain. I'm going to clear it. Yes, I know I'm going to clear that. So now there is nothing here. I'm going to say has height map. But I am also going to clear that height map because I want to start with a clean slate. I also want to make sure our operation is set to addition because I don't want anything to be taken away from our current filter stack just yet. And let's set this border blend range all the way up to 1 so that I have a nice crisp edge all the way to the very edge of our terrain. If it was something like 50, then it would be a little too shady for what we're about to do here. And let's make sure our level step is something about around 9 because we kind of really want to affect just something graphic here in this nature. All right, our terrain looks exactly the way it did before and didn't have anything changed from our settings here. We're going to go to edit the height map. And now I want to, let's go ahead and select flatten here. I want to go ahead and import my north and south arrows. So if I click import here, and then I've already created these east, north, south, and west PNG files in Photoshop. I'm going to import my north one. They are black and white, and I believe I have their resolution at 512 by 512. I think that's the default for the alphamasks here. So I'm going to go ahead and import and check our south icon. All right, all we have to do is just click on the north icon, and 600 is pretty good. I selected the flattened terrain because then, instead of the raised, because then we can set the actual height. So over here, if I in this area, if I hover my cursor, you can see the observer tool says that it's a -5. Let's change this to something around 50. And let's just see what kind of effect we can have. And I have my brush size set to 100, not 100, but 1. And I'm going to click just once here. All right, perfect. And that is our north slot. And we're going to go here and click our S. And I'm going to do the same thing over here in this region, S. Perfect. So now we are done with editing this height map. And if we zoom out, click F. And I just put this north and south in there just for us to see inside UE4 the differences between and know that we need to flip our Ys, which is this whole purpose that I'm showing you this. So now, let's turn off the heat maps there. So now we have our finished terrain. I've hoped that if you wanted to follow along with how I did this, I just made up something on the spot of that I knew that I kind of worked to a deserty, canyony type of terrain. Nothing too big, nothing too fancy. We're just trying to get the point across here. So the next thing that we're going to do is we need to export this. So we're going to go to the Export tab. We're going to click Surface because we're wanting to export the surface. We are going to select the height map, not the normal map. So the height map, the raw format is my favorite, but there is a plethora of other formats you can choose from. The best fit for the normalization. We're going to choose the window version of how it is being processed and not the Mac version. Make sure it's 16-bit. You can do 32, but I need to at least make sure it's 16-bit. Otherwise, it's going to look a little bit pixelated in UE4. We're going to change our game engine to Unreal as obviously. And here, as we did that, we have a few settings here that kind of show up. So the game engine scaling, and this is pretty nifty. Our X and Y scaling will likely always be 100 by 100%, but this Z scale is 89.57. And that's referencing to when you import this into UE4, you've got to change the scale of that landscape in the Z axis to 89.57. Now, the reason why this is if we hover our observer tools, we can see our cursor and we have our terrain information at the top left that the E for elevation goes anywhere from a negative value here to a positive value here. You can see our range is 458.58. So that is the total distance from the lowest point in meters to the highest point in meters. In Unreal, you have a maximum of 512 meters total from bottom to top when you talk about a 16-bit depth file. So that means it's just like in Photoshop when you change the levels of an image. You have the dark values and the white values, and you have all of the gray values in between. So for a 16-bit depth file, that's pretty much saying that between the blackest black and the whitest white on that image, there is 512 different levels of gray in between those 2 points. So that means it's 512 meters. So that's all that you have to work with in Unreal is 512 meters total for a 16-bit. So if you have something that is below that total range, so our range here is 458, you have to figure out what percentage of this range is of 512 to get this 89.57%. Now, if you have something that is, this range is 2,000 meters, for example, well, this Z-scale is obviously going to be way more than 100%. You kind of get the gist, but what they've done here is they've taken out that simple math away for you to figure out, and they've just given you that value. So let's just remember this number here, and that'll be much easier going forward. All right, the next thing that we want to do is make sure our Y is flipped. So I'm going to show you 2 different versions here. We're going to export this without flipping the Y, and I'm going to go ahead and hit export. All right, so here I'm just going to rename this as HEIGHTMAP _ and I'm just going to say test terrain, but I'm going to say that it is 4033 by 4033, and then I'm just going to put a lowercase z and then 89.57 to represent our height. You don't have to do this. Name this whatever nomenclature that you want. I'm just doing this for the tutorial purposes. We know this is our height map. This is a test terrain that we're doing, whatever you want to name it. This is the resolution that I know it is, and this is the Z value. Really, the big thing that I'm wanting to do is just save the Z value without having to write it down and keep up with the post-it note. So we're just going to go ahead and save this, and it's going to go through the export process. All right, perfect. Now it's done. Now, if we just open up our folder here, we can see that it is nice and inputted there. This time, we're going to select the flip Y option. Let's go ahead and export this as well. And we're just going to click the terrain that we made before, but instead right here, I'm just going to put in parentheses flipped Y so that we can know the differences between the two. There we go. And the reason why we have to flip the Y is just that some engines like Unreal change the way that the normalization is or how it's being calculated when it is imported. There's a whole technical aspect that probably explains it on the Unreal Engine 4 documentation that we're going to skip here. But just know that for any Unreal project, you need to just make sure that the Y is flipped here. So I'm going to minimize. Okay, so here we have the Unreal Engine editor open here. We're going to select a new project. I'm just going to select the 3rd-person project so that we can have something to work with. Desktop, maximum quality. I don't want any starter content, so we're going to be working from there. And we're going to say this is World Creator 2 _2 UE4 vid, just something like that. All right, we're going to create the project. Okay, so here we are inside Unreal Engine 4, and we can just zoom out here. All right, I'm not going to worry about creating a new level. This is just for import sakes, but I am going to go ahead and delete these walls here real quick so that whenever we import our terrain, we can just plop ourselves right on there. All right, so up here, we're going to go to the Landscape tab. And immediately it knows we don't have a terrain, so let's import a terrain. We can create one from scratch, and you'll see here, just real quick, some of the settings that I mentioned earlier in the video. So you can choose your section size, and these different section sizes or quad amounts per section size that I mentioned earlier is there. You have your 1x1 or 2x2 sections, and the number of components is maxed out at 32. We're going to, instead of create new, we're going to select import from file. Click this little 3-dot button, and let's go search for our file real quick. So I'm going to select the one that we exported first. So this is the temporary mesh that shows up whenever we import the terrain, but you'll see that automatically it has, without even having to worry about it, our height map resolution that we imported is 4033 by 4033, and Unreal recognized that exact resolution, 4033 by 4033. Now it's already set up the optimal section size, components, numbers, number of quads, everything is already predetermined based on that resolution. And you can go ahead and change these things. I don't really recommend it. I'll go into that Y in a little bit. But we can, if we remember, our Z height is 89.57. So right here under scale, under the Z height, we're just going to change this to 89.57. And let's go ahead and click import. Okay, so from this view on this particular export, you can see that the north is down here in the bottom left and the south is in the top left here. But I mean, how do you know which orientation you are in the real world? Well, the green color here is always the Y value. You can see that down here in this little icon down here in the bottom left. So the Y is green, the X is always the X value, and blue is the Z value. You can even see that here under the transformation tab here, the Y is green, X is red, and Z is blue. So you can see that in the Y value that the north actually should be up here and the south should be down here. So if we delete this, go back to the landscape tab and we choose our flipped Y version, click open, and that's already still the same. So we can hit import. So now in this version, we can see the north is in the correct spot and the south is in the correct spot. So this actually turned out to look pretty good in this engine. Now, as we know, this terrain is 4,033 meters by 4,033 meters. And that's all based on a 1 meter precision level, which means that for each meter, there's a quad. We got this. But what if we didn't want that 1 meters? What if we wanted it to be 2 meters, 3 meters, or a half a meter? Well, let's go back to World Creator 2 and let's walk through how we could adjust for that. So I'm going to just minimize this, open World Creator 2, and we have here our same terrain as before. So on the Surface tab, under the Base sub tab, we have our precision level as 1 meter. Let's just say we want to change this precision level to be something like 2 meters. Let's go ahead and change this. So really all this does, it just removes one of the level strength step sliders down here because as we've learned before, that's the one of the resolution levels that doesn't account for 1 meter. The highest one that we can get for 2 meters is level step 9, which adjusts every 2 meters. So here it doesn't look terribly different, and you could actually save up a lot of mesh by doing something this method, as long as it's not something drastically different. But as you can see, once we change this to 2 meters, our actual resolution is 2017. This just coincidentally happens to be one of the recommended resolutions for Unreal Engine. It doesn't always play out as nicely as this, but the concepts of what I'm about to show you work the same. So with 2 meters selected, we've changed our 4033 to 2017. That's it. We can work from there, and let's go ahead and export this, and we can make sure our Y is flipped. And since we changed our meters, look what happened. Our Z scale changed a little bit. It didn't change by much, but that difference in resolution was enough to change the overall point height to this. Now, this is completely up to you on if you wanted to keep that scale, because you can make this scale whatever you want. But if you wanted to make different terrains of the same scale for different LOD reasons, then you need to make sure that you use the same Z scale consistently between all your different meshes, for example. That's a completely different use case. So let's go ahead and export this. And I'm just going to select the same thing for flipped, but I'm going to go ahead and change the Z value just for consistency's sake of the tutorial. And on top of that, I'm going to do another underscore and say this is 2M for 2 meters so that I know that it's different from the others. All right, we have that exported. Let's open up UE4 again. Let's select this and delete it. Go to the landscape tab like before, and this time we're going to select the other texture with the 2 meter tab here. And remember, Z value is 92.07. So I'm going to open that. I'm going to make sure the Z value is set to 92.07. And now it has adjusted for the 2017 resolution because that's what our height map was. But as you see in World Creator 2, our terrain size is 4033 by 4033. So we need to match that. So here in UE4, we're just going to make sure our X and Y scales are double what they are now. So we're going to change these to 200%. So now it has enlarged itself times 2 of 2017, which should be 4033 by 4033. So if we import this, and as you can see, it has imported essentially the exact same terrain before. It's 4033 by 4033 in distance, but the resolution of this landscape is actually 2017 by 2017. Don't worry about this grid here. That's just a little thing in UE4 about the static shadows. You could change that temporarily by selecting the terrain, go into your details tab, going down to lighting, select static, and you can select it back if you want, but if you turn static shadows off, it just removes it. Really, that's just telling you that you need to build your lighting, but we're not gonna worry about that just now. So now we saw how it looked at 1 meter, and we saw how we can double this scale for 2 meters. You can also change these scales up here, but it's best to just scale it from straight import, but that's okay. So you can see our scale is 200 by 200 and our Z scale is 92. You can change these here. That's no problem at all. So now let's look at how we would like to see a denser level of subdivisions or a smaller precision level. We did 2 and 1, but what if we went half of 1? What if we did half a meter? So let's go back to World Creator 2 and let's change our precision level from 2 down to this half meter. And I wouldn't suspect that many people would go below the half meter down to a quarter or an eighth. Maybe an eighth would be okay. If you wanted to go for anything lower like this, I would say it's for a much smaller terrain size so that you can have a more intimate relationship with the character and the landscape for having an exaggerated amount of detail inside of your terrain. Like, you can do that, but just be mindful of the resolution sizes and the scaling that you'd have to do. So now we have taken our 4033 by 4033 distance terrain and essentially doubled its resolution. It is now 8066 by 8066, which is a pretty high density mesh here. I mean, this terrain looks a lot better. I can just tell between the two resolutions. It's double the resolution. But as you can see here, as we've learned in the previous explanation in UE4, this resolution won't fly. One, because it is an even number, as we learned that Unreal Engine does not like even numbers. It has to be an odd number. So you have some options. You could either work with the exact resolution that you have here, which is just fine, and I'll show you how you could work with that, or you can get a much closer resolution to one of the recommended UE landscape sizes. For science, we're just going to keep this, and I'm going to show you the other options that you get as you import into UE4 and how that affects. So as before, let's just quickly export this. Everything's the same. The scale is 87.39 now, so we'll export. I'm just going to select this one that we've been selecting, and now we're going to do 0.5 for the precision level. It's still 4033 by 4033, but we know it's resolution wise, realistically 8066 by 8066. So let's save this. All right, now that we've exported that, let's just close this and go back to Unreal Engine. So we're going to delete the terrain we had before. And again, let's go ahead and open the correct file that we're going to be working with. We select our half meter precision with a Z value of 87.39 and click open. And then we have that here. Let's go ahead and make sure our Z value is 87.39. So real quick, before we go any further, we remember now that this terrain is 4033 by 4033. So as we know before, we need to change our scale to 50% since it is exactly half of the terrain that we imported. But as you can see, if we look a little bit further, our height map resolution is 8066 by 8066. But the resolution that is being used here realistically is 8129 by 8129. That's because, again, like if we keep hitting fit to data, it's going to choose that resolution as the closest option. So what this does is whatever resolution height map that you import into Unreal Engine 4, it's going to make sure that it chooses the next best resolution that is a higher resolution above what you imported. So what does that mean? If our actual height map is 8066 and UE4 is using 8129. Does that mean our scale changes? I mean, we just changed it from 100 to 50, so it should be 50, right? Well, yes and no. Let's go ahead and import this and I'll explain a bit further. Okay, so now it has imported our terrain, and to us, it really doesn't look that much different than before. But we know that the resolution of what terrain was made here is a little bit bigger than reality that we made in World Creator 2. So what happens is, let's go ahead and zoom here to the edge. Okay, right here is a good example of what happens. So the height map that we imported is 8066 by 8066, and that got shrunk down to 4033 by 4033. But don't worry about that, because I know that we've scaled this. If you do a half meter precision, you always need to scale down to 50%. If you do a quarter meter precision level, then you need to scale the terrain down to 25%, and so on and so forth. So if you import a height map and Unreal has to use a height map resolution that is higher than what you imported, that means it doesn't scale the 8066 by 8066 that we just imported. It doesn't stretch the terrain. Well, it does. But as you can see here in this example that we zoom in, this line here represents the 8066th pixel. So to fill up the rest of the pixels to match up to the 8129, I believe it was, that Unreal created, it's got to basically stretch that last pixel. So it does stretch the terrain. It stretches the last pixel just like you see horizontally to meet that resolution. But the rest of your terrain, everything else scale-wise, is exactly the way it is when it's imported. Unreal's not going to unanimously or evenly scale all of your pixels to stretch to its import size. It's essentially just going to say, hey, well, we need some information to fill up this gap here that you've made us use. We're just going to expand that last pixel. So knowing this, that means you have a couple options from this point that you can go about with. You could A, import it as is and let Unreal expand that last set of pixels to match up. And you could hide that a little bit in UE4 by doing a little bit of sculpt magic, or if you're doing an island, it doesn't really matter, because if you're doing an island, that pixel stretch, it's going to be underwater. You can cover up that with some other meshes or foliage that kind of hides that stretch, or it may be outside of your playable box. Or heck, if you're just using this for cinematics, who cares if that last few pixels is stretched a little bit? You're not going to see it from a rendering perspective if you're focused, somewhere inside here, or if you're meshing a bunch of different landscapes together. So what's your second option? Let's go ahead and delete this terrain again and re-import it. So here we're not going to change really much. We've got the same height map resolution that we've imported. These scales are all going to stay exactly the same. But what we do change is this overall resolution. Now, if you could do some math, what you could do is, instead of having the finished terrain have a resolution higher than your imported height map, you could, if you want, change this resolution to be as close as possible to a resolution value that's below the number of your imported height map resolution. So let's go ahead and just knock this down to one slot as an example, and we're gonna knock this down to one slot. You can see by doing that, it's basically just removed one of the number of components, and you can do some math to try and maybe figure out something a little bit closer. I think there's one or two other resolutions that we could have done a little bit closer if we had a 1x1 or the quad size is different, but that's not the point. The point is the overall resolution that's being made on the terrain is less than that of what the height map is. So what does it do? Well, it won't shrink the terrain, just like it didn't scale the terrain to fit the 8129 that we had before. It's going to keep that scale of your height map exactly the same. But what it does do is it basically crops your imported height map to match this overall resolution, which is not necessarily a bad thing either, if, depending on your application. If you just want something that's as close to 8K, then for visuals, or even if it's for a game, that's okay. It doesn't have to be perfectly 8K if you didn't want it to be 8K, because you can fudge some stuff. But that's your two main options to understand when you import a terrain that's a different terrain size than what Unreal is capable of handling. So you get the gist of how to use the height map, but what about the other stuff, such as the textures? To do this, I'm going to use one of these sample terrains on the World Creator website. So here on the main page, if you go up here and click sign in, and after you sign in, you'll come here to the customer portal. And the sample terrain that we are going to use is down here, the Sandstorms 1 terrain. This is a really good sample terrain that you can load and learn to figure out how to use some of the filters and how they go about texturing. And I recommend opening up all of these sample terrains just as a gist to understand how they've used the filters, how some of the community members have taken this and filtered it. So it's a really good way to really get the gist of some formations and functions inside World Creator 2. Okay, so once you've got this loaded, you will see that the terrain size here on the right is 2048 by 2048. Let's just go ahead and use one of Unreal Engine 4's recommended sizes. I'm going to choose 2017 by 2017. So let's go ahead and change this. And just let that regenerate for a while. Now we have converted our 2048 by 2040 terrain into a 2017 by 2017 terrain, which will fit much nicely in UE4's ecosystem. And our precision level is just fine, so we don't need to worry about that or change any settings. We're really just wanting to show you the heat map exports for the textures. So the next thing we need to do is let's go ahead and go to our texture tab. And I'm just going to go ahead and name this layer something like LAN. So let's erase this. And let's just say land. The name of the layer isn't too important, but it's going to be the beginning name of how the export does the exporting, basically. So it's not terribly important on the name of the layers, but it could be important if you have several layers of textures instead of different textures per layer. It would be really nice to name this layer appropriately if you have textures based on erosion or texture layers based on rocks or grass, anything like that. You want to make sure that you're organized. But what really is important as far as UE4's ecosystem is the taglines for each one of these textures. You can see we have the first texture selected here, provided by the blue outline, and the tag name here is set to default. We need to make sure this is something that we will understand on what it is once we import it into UE4. So I'm just going to name each one of these based on layer 1, layer 2, layer 3, and layer 4. Not that they're layers in World Creator 2's standards, but that will understand them as layers in UE4. So I'm going to go ahead and name each one of these as their appropriate layer. Great, there we go. So assuming you have everything the way you want and named correctly, let's go ahead and click on our export tab up here at the top. And then let's go down here and select heat maps. I know there's the texture tab here to the left. That's not exactly what we're wanting to do. The texture tab will export the actual color maps of the textures or the diffuse map of the textures. So it's not going to provide you the information that we're going to want inside UE4 unless you're planning to use the exact same textures inside World Creator 2 to UE4. Now you may want to do that, you may not want to do that, but you don't really have to use the textures, the color maps from World Creator 2 to UE4. You could just reuse the exact same texture that you used before from your folder structure. The other thing that the texture tab at the top here does is you can export the entire terrain as one texture. As you can see here, our terrain has multiple different colors and shades to us, 4 different landscape textures here. So if you didn't want to export 4 different textures into UE4 and you just wanted to export this whole terrain as one color texture by itself, just for like study purposes or something like that, or if you're wanting to use this as a single texture as a mountains or terrain in the far distance that your player will not actually be activated on, but as just a view distance, you can certainly do that and it'll actually save you some time. I just find doing the texturing inside UE4 a little bit easier as you're using the real textures that you used to begin with to texture inside World Creator 2. So here in the heat map tab, we want to make sure we choose what type of heat map we want. So under select type, let's just select textures. You can select what media format you want. I'm just going to, for simplistic sake, use PNG, but I'd recommend something like TGA because it'll be a 16-bit version. They're going to be adding a 16-bit version of PNG for heat map exports, but I'm just going to go ahead and stick with this version as is. And again, make sure that you flip your Y so that we can match up with our height map of this terrain. As well as you can see the 4 different textures that we renamed before. You can see that the layer name is land, and the tag name for each one of these textures is layer 1, layer 2, layer 3, and layer 4, just like we had done before. Oh, and I see that the one of them is not capitalized, but that's all right, doesn't matter. But as I mentioned, all the tags for each one of these is appropriately named. So from here, I'm going to just go ahead and do something you probably didn't expect. I'm going to deselect the first texture. Now, why do this? Well, this is because there is not really any need to have an alpha mask or a heat mask for the base layer. This layer 1 is going to be basically a blanket the entire terrain, and the other textures on top of this one will overlay the differences. Doing it this way will also help reduce any errors in the texturing process in UE4. So if we were to provide a heat map for layer 1 inside UE4, if there was any unforeseen gap in the alpha masks, then what's not being textured in UE4 will show up as black or gray, or if you're doing debugging, it'll show up as red or something like that. So to make sure that we don't have any weird glitches in our texturing, we're just going to not use the heat map for the first layer, and inside UE4 we're just going to make sure that particular texture covers the entire terrain, and the other corresponding textures will filter on top of it. From here, let's just go ahead and export like before. And where we're going to save it, I'm just going to change this from heat map to WM for weight map. You can see here in this file folder that I've already made, I have already gone and exported the height map to this. So it uses the same conventions that we talked about earlier in the video. I have HM for its height map, the size of the terrain, and I just went ahead for my purposes, put the Z value that I'm going to have to scale. Okay, so here we are back in Unreal Engine 4, and we're just going to go ahead and go through the process of importing everything just like we did before. So we're going to go to the Landscape tab, import from File, going to select the open 3-dot icon here, and I'm going to select the height map that I had exported earlier, so 2017 by 2017, and a Z value scale of 50.27. So we're going to open this. We're going to make sure our Z scale is set to 50.27, and you'll notice that Unreal has automatically sized this exactly the way we want it. So let's go ahead and just import this as is. All right, so this imported just great. So now let's go ahead and add those textures, or at least texture this landscape based on the alpha masks that we exported from World Creator 2. So I'm just going to go ahead and just right click and create a new folder down here in our content browser real quick, just to get a little structure. So I'm going to name this landscape. I'm going to double click inside here, right click, and I'm going to select the material icon. We're just going to name this LM for landscape material and main. You can name it whatever convention you want, but this is just a general idea to get you guys started. So I'm going to double click on this icon here. It's going to open up our material. Let's go ahead and just dock this with our main screen so we can have a better view. All right, so this is going to be our export node here. So we're going to plug in everything that we create here on the left into this output node, and that's what's going to be generated onto the landscape, so to speak. So the first thing that we're going to do is we're going to right click and type in landscape. And this will show every single landscape node that UE4 has that you could utilize. So these are the main ones that you want to deal with. So the one that we really want to make sure we use is this landscape layer blend node. So with this node, there's nothing really going on yet. And if you come over here to the bottom left under the details panel, you see this little plus icon where we can add elements. Let's go ahead and click this 4 times. And these are the 4 layers that's going to represent the weight masks or the alpha masks that we exported from World Creator 2. Let's go ahead and expand each one of these. And then you have some options here, but we're just going to worry about right now is naming these. So we're going to name this base. We're going to name this actually layer 2, only because we're going to match this layer 2 with the layer 2 nomenclature that we exported from World Creator 2. We're going to name this layer 3 and then layer 4. And we can go through the blend types. There's 3 different blend types that I'd recommend you look up on Unreal's documentation for. But for right now, we're just going to ignore all of these settings. We just want to set up our basic layer structure and just to show you how that the import works. And then let's just go ahead and link these two together. So we're going to right click and hold on the export slot of the layer blend node and put that onto the import slot of the export node here under the base color. And this is the same principle for all of these other inputs. You would copy this layer blend node and then each export would go to its corresponding connection. But we're just going to focus only on the base color here right now. And I'm not going to import any textures. So we're just going to do this based on color. So how do you add just a plain color to this graph? So if you hold the number 3 and click, it's going to give you a 3 vector node here, and you can right click and convert this to a parameter. And we're going to name this layer color 1. And basically, as you can see, this is going to give you an RGB value that you could plug in for a base color. So if we double click this, we can select whichever color we want. And I just started with a base light color here, and I'm just going to take the export slot here and drag and connect that to the first layer input slot of the layer blend node. We can do this a few more times, so I'm just going to select our layer color 1, hit Control C, and then hit Control V a few more times to add more colors. And we're going to have to rename these because since they're all for layer color 1, they're all going to be identical. So let's select the second one here and change it to layer color 2. The third one, layer color 3. And the fourth one, layer color 4. So let's go ahead and just change some of these colors real quick. And then I'm going to go ahead and connect all of the RGB export slots to the import slots of the corresponding node. And here now we've got all of our nodes that we need to start the base understanding of this connected. Our layer color 1 is connected to the first layer base, color 2 connected to layer 2, so on and so forth. So this node is really going to be the powerhouse to understanding the different alpha masks once we import those here in a little bit. So I'm going to go ahead and just hit apply and save. Now let's go ahead and go back to our main screen. If we want to, you don't have to, but if we want to, based on how you set up your materials, you can right click your main material and you can create material instance from this. Let's go ahead and just leave it named that way. It's L main instance or LM main instance. And if we double click this, and as you can see, this setup is a little bit different than before. It doesn't show any node graph, but it shows all the parameters that we recently made. If we go back to our main material layer, we've basically created each one of these nodes as a parameter. As you can see, the param text right here in the very front of the RGB color values, that stands that is a parameter value, and you can go in and change these on the fly if you want to without even having to go into the main color. And to do that, you just click the checkbox here. You can double click the color and change the color on any instance. So basically you could use this material instance 500 different ways and versions that is based off this parent graph. And to change parent graphs, you can see here under the general, you can change the parent graph of whatever material instance that you want. So with our landscape selected here, we could either choose the material or the material instance. I'm going to click and drag the material instance over, and you can see over there on the right side, the details panel, the landscape material has already hovered with a green dashed line saying that that's active and you could place this here. So we're going to go ahead and place this here, but then nothing happened. What's going on? If we go to our landscape tab and then go to the paint sub tab of our landscape tab, click that and you can scroll down and see all the 4 layers that we created in our material library. So how do we go about getting our layer information applied to the actual landscape? Because we technically did that here with the landscape material, adding it to the physical mesh. Well, what we need to do is these are our layers, but we don't have any layer information for them, meaning the layer style setup. So what you need to do is you need to create layer info. And for this first one, I'm going to choose non-weighted blend layer, and I'll explain that why here in a second. So let's choose a location where we can save our layer information. I'm going to choose the landscape folder that we've got here, and I'm just going to let it save the name that it's giving me here. And then after I've given it that layer info, look what happened. It applied that base layer texture, base layer color right here, layer color 1, to the entire terrain. If it doesn't apply to the entire terrain, you could actually right click this layer and then select fill layer. and then it'll go ahead and take that texture or color and apply it to the entire terrain, or you can clear it and just completely delete that layer information. But this, as I've said before, we don't need to add any alpha mask to it because it's going to be our base color. It's the very bottom of the terrain, and all of these corresponding layers are what we're going to basically put on top. So now we need to go ahead and just do the same process for these other three, but this time when I click the plus, I'm going to go ahead and select weight blended layer. And I'd recommend going to Unreal's landscape guide on their documentation to understand the differences between these two, because a lot of variations can make a lot of sense for certain applications. But for this, we're just going to get the general understanding of how to get your alpha masks from World Creator 2 to show up. So that being said, I'm just going to go ahead and create these real quick and name and save them in the same location. All right, so we have now created the layer info for our 4 landscape textures, but the other three aren't showing up. Let's go ahead and go to layer number 2 and let's right click. And if we go here under layer actions, we can see import from file. Let's go ahead and click that. And if you look here, this is the alpha mask that we've exported from World Creator 2. And if you see here, it's layer 2, which is what we named it in World Creator 2. And that for us is to understand that this layer 2 image here corresponds to the layer 2 that we've named here. You can do this nomenclature any way you want, but that was just how I'm going to explain it to you for this purposes. So let's select this PNG here and click open. And after a few seconds, you can see the layer 2 has been alpha masked onto the terrain. So if we zoom around here, we can see that it is clearly defining the 2 different textures. We have the lighter color, which is the base layer, and this slightly darker color, which is layer 2 here. Let's go ahead and do our other 2 here. Let's right click, import from file, select layer 3, hit OK. And we've added layer 3, so let's go ahead and select layer 4, input from file, select our layer 4. And as you can see here, we have got all 4 of our layers in, and they have come in just perfectly. So you can see you could do some pretty amazing things with exporting these alpha masks from World Creator 2 and using them basically as a base inside UE4. There's a lot more that you can do. For instance, if we still wanted to paint something, we can select which layer we want to paint with. And I'm just going to click here and drag. And you can see I'm now painting based on layer 4. Or if I want to choose layer 3, I can paint based on layer 3. Now, this is the correct way to set up the paint part of UE4. There's a lot more that you have to do inside material functions, materials, and material instances. And as I said before, if we don't like one of the colors here, we can go to our material instance, and let's just say we want this last layer to be something else, like a there we go, like a hot pink. Just select OK here, go back, and look at there. We can see it in live action. Let's just pull this out here so we can do another one. Let's say our base layer, we want it to be somewhat of a green. We can change that, or layer 2, make that something like a red, like a really bright orange red. And let's just try layer 3. Let's do some type of really light, really bright blue. Ooh, that's something, right? And another thing to keep in mind that is, I know we used colors here, but if you start getting into textures, you're going to have to think about the UVs of that texture. So let's go ahead and right click and type in landscape again. And if we see this landscape layer chords, we're going to click that. And what this is going to help map your UVs. And then if we type in texture sample, right here, texture sample, this is just an idea. So these landscape chords are going to generate the type of UV mapping that you are in the X and Y direction, as well as or the overall scale of the textures. And if you connect these two, And then just like we did with the colors, connect the RGB to the layer blend and the layer blend to the base color. That's going to help set up your UVs amongst all your textures in this node. There are several ways to do this. You could also do the world position, and you can base it off the world position, which is a completely different level of doing it. And we're not going to get into that now. If you'd like me to go through some material graphs later on, just let me know in the comments, and I'll be sure to create videos based off that and how you could set up master materials, material functions, and how you can do blending effects and water and everything like that. So just let me know, and I'll be sure to try and get that for you. But this process that I just showed you is just the absolute bare minimum to utilizing the HEIGHTMAP and HEATMAPs from World Creator 2 to UE4. The same process can be used to export and import HEATMAPs and generate UE4's procedural foliage for things like trees and grass and rocks and roads. The same application applies as far as exporting from World Creator 2, and you could use those alphamasks or weight mask or heat maps or whatever you want to call them in UE4 at your discretion. I would highly recommend going to Unreal's landscape materials documentation on their website. This is going to be a really handy source to understanding all of these nodes, how to set up some material graphs in a more complicated way. And also it's going to help explain way more in depth of understanding the entire graphs apart from what I'm showing you here. There is a lot you can cover, but the basic understanding is you export the heat maps from World Creator 2 and you could use those in any way, shape, and form inside UE4. And one of those ways is as weight maps or alpha masks inside the engine. So that pretty much wraps up the basics to getting your landscape into Unreal Engine 4. In the next video, I'll be sure to show you how to import massive terrains from World Creator 2 into Unreal Engine 4's World Composition tool. It's a really neat feature and I can't wait to show it to you. So thank you guys for watching, and I'll see you in the next one.